Video will show how to find a local minimum or maximum of a function of two variables. In our problem, we have a scenario in which we generate revenue from selling two different types of umbrellas, and we have also associated cost of production. So in order for us to maximize the profit, we have to find the profit function, and the profit function will be also of two variables, and as always it will be revenue minus cost. So the revenue function that we have in this problem is from selling X $20 umbrellas, so that means we'll make 20X, and selling $25 umbrellas, Y thousand of those, so 25Y. So 20X plus 25Y is our revenue, and from that revenue we will have to subtract the cost, and the cost function is given. So we subtract 3x squared minus 3xy plus 3 half y squared plus 32x minus 29y plus 70. We can combine like terms to get the following function. So the profit function is negative 3x squared plus 3xy minus 3 half y squared minus 12x plus 25y minus plus 29, that's 54y minus 70. And now to find the local minimum and maximum, we have to find the first partial derivative, second partial derivatives, and then just follow the procedure. So the first derivative with respect to x is negative 6x plus 3y minus 12. The first derivative with respect to y is 3x minus 3y plus 54. Now second derivative with respect to x will just be negative 6. A mixed derivative first with respect to x, then with respect to y will be 3. A mixed derivative first with respect to y, then with respect to x will be 3, and the second derivative with respect to y will be negative 3. Next, we take the first derivatives with respect to x and y, and we create a system of equations. So in our case, we have the following system: negative 6x plus 3y minus 12 equals to 0, and 3x minus 3y plus 54 equals to 0. So before we start solving it, we can reduce everything by 3. So for example, we have negative 2x plus y, and if we add 12 to both sides and then divide by 3, we get 4. And now here same thing, dividing by 3 gives us x minus y, and subtracting 54 from both sides and then dividing by 3 will give us negative 18. So solving this system of equations by elimination gives us the following solutions. So y will be equal to 4 plus 2x. So when we solve for x, we also find y. And therefore we have one critical point, 1432, and to classify this point as a relative mean, max, or saddle point, we have to compute the d value. So to find the d value, we're just going to use the formula, and pxx is -6, pyy is -3, pxy, or the mixed derivative, is 3, and the other derivative is also 3. So these two mixed derivatives are the same. So we get the following expression to compute. 18 minus 9 is 9. So 9 is positive. That means what we have is either minimum or maximum. And to determine whether it is a minimum or maximum, we are going to look at the second derivative with respect to x twice. And it is -6. And since -6 is less than 0, we classify this critical point as a relative max. So to answer the question, how much of each style of umbrella should the company produce and sell to maximize the profit, we would say the company should produce and sell 14,020 umbrellas and 32,025 umbrellas.